Welcome back to LearnALOTL. In this video, we're going to do a worked example of proving a classic derivative in calculus, and that is that the derivative of log x is 1 on x. Let's jump into it. So in order to prove that the derivative of log x is 1 on x, we have to remember what the derivative is. What is the definition of the derivative? And the definition of the derivative is really this particular limit. So it's the limit as some quantity, I'm going to call it h, tends to 0, of our function with an argument of x plus h minus our function with an argument of x over h. You may have seen this before as a differentiation from first principles, and by first principles really means applying the definition of the derivative. So this limit, if it exists, is what we define to be the derivative. So our next step in this particular limit is to immediately apply a particular characteristic of the log function, which is that subtraction is actually going to turn into a division of the arguments. So x plus h, log of x plus h minus log of x is the same thing as log of x plus h over x divided by h. So our log laws coming in handy there. Then we can rewrite this as a limit as h tends to 0 of log 1 plus h on x over h. And we can now apply another characteristic property of logarithms, because that over h in the denominator is a prefactor. So it's 1 on h times log 1 plus h on x. So we know that that's the same thing as the limit of as h tends to 0 of log of 1 plus h on x to the power of 1 on h. And now I'm going to do a quick substitution. I'm going to let some quantity, let's go with z. Let's let z equal 1 on h. So z is going to tend to infinity as h tends to 0. And we have the limit as z tends to infinity of log 1 plus 1 on zx to the power of z. That's all in the log. So we have that the derivative of log x is equal to this limit, and here we can actually apply Euler's famous limit, that the limit as n tends to infinity, 1 plus 1 to the n, 1 plus 1 over n to the n is equal to e. And there's actually a slight adaptation of this result where we have some quantity a instead of 1 there, and that's e to the a. So if we apply that limit, we find that our limit as z tends to infinity of log of 1 plus, let's say, 1 on x over z, that's the same thing as what I had before, to the power of z, is the same thing as log of the limit. So I'm using here the continuity of the logarithm. So log of the limit 1 plus 1 on x over z to the power of z, that's equal to log of e to the 1 on x, which is 1 on x. That's what the logarithm does. It kind of undoes an exponential. So if you take the exponential of 1 on x, you get e to the 1 on x, and then you take the log of that, you just get 1 on x back. So there we go, we get our result. So that was just a quick worked example there. Hope you enjoyed this shorter video, and I'll see you in the next one.